Okay, so this it's checking if it's playing. So yeah, so now this is how you can factory reset your device for DeepLens. So once you have these things ready, so first thing you need is DeepLens keyboard, USB hub, micro HDMI to HDMI or anything that connects to your external monitor, USB drive that we just partitioned with the files that we need, and SD card that has what do you call it, the recovery Ubuntu bootable installed. So what's gonna happen, so the reason why we're doing this, two separate things, is for, I'm not sure about the older version, I think 2018 version, but 2019 version, there are two USB ports, but registration one is useless. It doesn't work for some reason. Yeah, so technically you only have one USB port. So when the critical part of the factory reset is to partition one USB drive with one with the bootable part and one with like files for actually reinstalling the firmware. Like the Ubuntu, like the image. But you also need another USB port for entering the BIOS, which is required to kind of reboot from this drive, USB drive. But then in this case, you only have one USB, so it's like, what do you do? And I've read a few forums and different pages, and it seems like I'm not the only one. So one of the ways to do it is use the SD card as the bootable source for the recovery Ubuntu, and then from within the recovery Ubuntu, you access the files in this drive to run the setup script, which does everything automatically, which takes care of all the installation and like partitioning in the storage space within this, which comes with 16 gigabytes, so it does all the things automatically. So our goal here is to take this device, get it, enter the recovery Ubuntu using this SD card, and we're gonna manually run the script to do the installation from this drive. Technically, the way they designed it should work right away, but I guess in this case we only have one USB drive, so we'll have to go with this route. Now, if you bought the 2019 version, so you should have gotten a 32 gigabyte SD card. The thing is, technically, you don't really need this. You don't need the SD card plugged in here. I'm mentioning that because initially I thought I couldn't use the SD card slot because it needs some sort of like external storage for it to boot up and like work properly. But it seems like it already has like an onboard storage, 16 gigabytes. So this is just like additional thing that they added just so you can use it for different purposes. In this case, we're going to use it to boot into the recovery Ubuntu. So these are already set up on these two, SD card and USB. I'm going to plug the SD card in. My goodness. Gotta use your thumb to get one in there. And as of now, I'm not gonna use this yet. So hub, USB, stay here for a bit. Now I'm gonna plug in the keyboard into the back of it, not the registration because it doesn't work, but into the other USB port. I'm gonna plug in the micro HDMI, and then the power source into this thing. Now, ideally you would use a computer monitor, but this one is all we have at the moment. So I'm gonna be doing turning off and turning on here and there. So just ignore what's going on here, but focus on all what we're doing in this area. So as of right now, the device is off, and in order to we're gonna try to enter the BIOS. So to do that, we need to press the escape key like repeatedly. But initially, I thought you had to go like this the whole time. So I was just sitting there and just doing this. But to get into it more consistently, you're supposed to turn it on and just calmly do this, and it should go into it right away. So we'll see if we succeed the first try. So I'm gonna turn it on. I'm gonna start pressing it. So dang it, I missed it. So this is like the default booting sequence into the, I guess, the main booting image. So it's gonna take us into the AWS DeepLens, the default one. So, oh, we also need a mouse. So yeah, you're gonna have to see the screen multiple times if it doesn't work. But now we're just gonna turn this off. To wait a bit, and we're gonna try again. Please. No! It's okay, this happens a lot. Okay. Okay, we're in. So I think the key thing here is to press beforehand and then turn it on, but I'm not gonna try to do that again. So anyway, once you're in here, you're gonna go to boot from file, the fourth option. If you go in there, you're gonna see a thing called boot. I don't know if you can read it on the screen, but it says it over there. And that is, so the BIOS is finding the bootable drive, or in this case SD card, because we labeled it boot during our partition the way we did it. So we're gonna press it, and this is coming from the SD card, not the USB, because USB is not even plugged in at this point. So once we press it, and then we have to go to EFI, which should be in the third row, and then there's boot. That's the file that we just partitioned, well, previously. So we're gonna press it, once again, .EFI, and this should take us into the recovery Ubuntu. So think of it as like a temporary OS where you can run your script to fix the OS that's broken in the other part of this device. So the device comes with 8 gigabytes of memory and 16 gigabytes of storage. And 16 gigabyte is where the device's OS lives. But right now we're kind of putting this in a situation where that OS is corrupted, so we need to factory reset it. But to do so, we need another OS, temporary OS, recovery OS, where we can run the script and files to reinstall the original OS back into the 16 gigabyte space. We are booting from the SD card where the recovery OS lives. So now we're on the screen. So this is not the DeepLens OS, it's the recovery OS. I'm not keep repeating myself. But now this is where you take the hub. So unplug the keyboard and plug in the USB where the new OS lives, along with the install script, install and plug in the USB, keyboard, and also the mouse, just to make things a little bit more easier. And plug it into the back of this thing. And the mouse should, oh my goodness, should work. Yep. And then the middle thing was just, it disappears once you start moving your mouse. So if you look at closely, oh, I don't know if you can see it. That's too bad. Okay, so I promise that one says flash. That one says boot. So basically go to your, find your USB drive storage where all of these things live. These are the files that we downloaded and partitioned and, well no. These are the files that we downloaded, partitioned the USB drive for, and then we moved it in here. This partition I believe is NTFS. Which is necessary. Now I'm pointing that out because sometimes, I guess depending on where you partitioned your USB drive, it can become corrupted, but it's not an issue because it's like a common issue apparently. So there's a thing called NTFS fix, and oh, give it a sec. Okay, so we're going to, okay, sorry, so sometimes the USB drive can be corrupted, the one that you partitioned as NTFS formatted. So there's a tool called NTFS fix, which is already pre-built in within the recovery OS Ubuntu. Now to run this properly, you're supposed to detect or figure out what the USB drive is called. To do so, we need to type sudo gparted. Now all these tools are already pre-installed within this. So as we can see, you probably can't see that well, but my apologies. But yeah, so you can see that there are options here, and find your drive, USB drive. Now I know this one is the USB because the storage on this one is 64 gigabytes. Yeah, 64 gigs, and it says like 59.75 gigabytes. So I know it's that one. I know the middle one is the onboard storage because it says 14.62, around 16 gigabytes. And the dev, like the first one is 29.72 gigabytes, which it's very close to the SD card storage, which is 32 gigabytes. So I'm gonna select the dev slash SD. Actually, I don't have to select it, but just remember that what your USB drive's name is within the system. In this case, it's /dev/SDA. So what I'm gonna do is, well, I'm gonna /dev/SDA. I'm going to quit gparted. I'm gonna take that and type sudo ntfs fix, assuming it's been broken, and then type dev/SDA, which is referencing to the USB drive that's currently assumed to be corrupted. I'm just gonna run it for the example sake. And oh, whoops. Yeah, I forgot that the drive is partitioned to sections. So I need to find, so if you partitioned your USB drive for some reason into two, in this case, I partitioned into two because originally I tried to use this also as a bootable drive. But in this case, we're not using that one, but we need to fix the NTFS one. So we need to go onto the USB drive and then look at the left column, and it says, and each of these kind of are named which partition it is. So for the NTFS, it says /dev/SDA2. So remember that. And we're gonna run sudo ntfs fix and /dev/SDA2. And since this partition isn't technically corrupted, so it probably shouldn't do anything. But I'm gonna press it, and it says refusing to operate on read-write mounted device. Interesting. Okay, well, I guess since it's not corrupted, it's not doing really much. But yeah, when it does say like corrupted, just follow these steps to fix it and get it to work. So yeah, so far everything's running. Now we're gonna focus on this script called usb_flash.sh. What this script does is basically take all these files and use them to reinstall the new image of DeepLens, which are present right there. Now, before we do that, we're going to we need to remove everything in the onboard storage. So we're gonna go to gparted, and it's gonna open up again. And we're gonna go under the 16 gigabyte one. And here we have a lot of stuff going on, but we're gonna erase all of this. And to do that, we need to go to device, create partition table, and then click it. Cannot be where in news. Okay, well, I guess I'm gonna. So if you see any of the like key it looks like a little key symbol. It means it's like plugged in or mounted, so we're gonna unmount it. And now we're gonna try create partition table. It says warning that this will erase all data and entire disk of this thing, dev1, in this case dev/mmcblk1. Now we do want that, so we're gonna press yes, but before we do that, we're gonna set to GPT. I don't know why GPT, but yes, GPT. So GPT and press apply. It's deleting everything. It's gone. It says it's all unallocated, all 16 gigabytes. Well, it says specifically 14.61 gigabytes. So cool. Now we have a clean onboard storage. And now we're gonna run this USB_/flash script and hope that it works. So now we're gonna go into, oh crap. We're gonna go to the directory where this is. Oops. Interesting. Let me see. Oh, I think it's because I'm already there. Yep. So we're in the directory now. I'm gonna do sudo /usb_flash.sh. Yeah, the way you run shell scripts on Ubuntu is to / and then the file name. So we're gonna press enter and it's gonna go into the setup stuff. Yeah, so if it asks you like, do you want to continue, just press Y and then it's gonna continue. And right now we are reinstalling it. It says 6,000 blocks, 7,000 blocks written. It's gonna keep increasing until the size of the image, I believe it's like 8.2 gigabytes. So when it's near like 8,700 some megabytes, means it's finished running. Well, now from now on, it's gonna work flawlessly, hopefully, hypothetically. But while this is running, I'm just gonna talk about a few things that might happen. Sometimes, for some reason, the image that you downloaded is like corrupted when it's downloaded. So the script is going to detect that the image that you're trying to install isn't quite correct. The way the script does that is it does the hash, MD5 hash like check. So for those who don't know what MD5 hash or hash is, it's basically you take this data and you pass it through this little thing called MD5 or SHA or something, and it's like a little black box thing. You plug it in, it's gonna spit out some like fixed characters, and those characters are consistent if the input data is consistent. So basically, instead of checking to see if the file is, let's say there's file A, file B, and you want to check if those two files are exactly the same. Instead of, you could compare like letter by letter, like byte by byte, but then if the files are too big, like 8.9 gigabytes big, you don't want to do that. But instead, you want to pass it through a hashing function, in this case MD5, and see if the hashes are equal to each other. If they equal, it means the files are exactly the same, hypothetically. So there is a file called image dipcam 19ww 19.5 tpm.md5. If you open this, it gives you this file with this hash. It's only this long, so you just compare that to whatever image is being installed. So we hope that the image underscore deepcam underscore 19ww 19.5 dot underscore tpm dot img file hash matches this hash. Now, for some reason, when I first tried this installation, it ran into the issue of hash not matching. So I just have to re-download the file from the AWS website and do all the steps again, and it worked. So yeah, I don't know why that happens, but I guess it has to do with like downloading image issues. But okay, now we're close to 8,000 megabytes. We'll just wait here, and it's gonna run the MD5 check after this. Now, when you get bored or if you get stuck on this whole process of running the script and installing, it's good to read over the script file, the usb_flash.sh, just to see what's happening and what might be the issue is. So yeah, I hope that this just goes through, because I really don't want to re-download the new image. The new image is like, yeah, it's like 8.9 gigabytes, so it takes a while. So yeah, please. 8,460, 8,500 megabytes. Almost there. Almost there. 8,600, 8,700. And it's done. So it's gonna say like 281,920 plus 0 records in, and then same number records out. I guess that's good if it's like that, but what really matters is what happens after this, which is where it compares the hash of the image installed and expected image to be installed. And I think this part takes a while because they have to convert the whole 8.9 gigabytes into the hash number. So we're just waiting. Now, in the most ideal world, this whole script is supposed to run automatically when you boot into the USB drive. But since there's only one USB drive, like I said from the beginning, this extra step of manually doing this is required. So we'll just wait. I mean, it'll be nice if you can actually see this, but oh my goodness. Yep. Anytime now. Oh. Okay, yeah, it just, okay, well, it just went all the way up, but yeah, it's going crazy now because it's working. Yeah, so I think what it's trying to do now is it's taking, well, it's gone. But so what it's doing is it was like repartitioning stuff on the onboard drive, 16 gigabyte space, and reinstalled everything, and it should reboot into a brand new OS. Fun story. The reason why I had to do this was because I forgot the password for the SSH to the device, or the password to the device. So sad beans. So as you can see, this is the normal boot up screen, and hopefully we'll be taken into the new OS. Yes. So yeah, there is the new OS and everything. Oh. Sorry, the floor is like hardwood, so my knee hurts when I move around. So FYI, the new OS, when you first started off, the default password is AWS_can, and it makes you set a new password. Current Unix password, and then enter the new Unix password. Make sure you write it down. Oh crap. And you are now in the AWS OS. I'll just call it that. I'm not sure why they use Ubuntu 16.04. I'm sure they have reasons. And I don't know Linux that well. But yeah, we're in. Those are little icons over there. But yeah, so that's how you go through all the boot sequence. And this is the solution for the case where your device only has one USB port, actually working USB port, and you have no other way of installing or plugging in the keyboard and the USB at the same time. So yeah, apparently the USB hub could work, but it's very unstable, and also the way the BIOS works is, from what I understand, BIOS kind of goes through all the ports that the devices that are plugged into the device, the hardware, and it just shows like what's currently plugged in. The thing about BIOS is that it's such a low level software that if there's a hub, like a USB hub, it's not able to detect, or it has a difficult time detecting other devices that are plugged into the USB hub. So it's better to plug in directly. I spent like good 3 hours doing this, and the hub like didn't really work for me. So yeah, this is I guess a different way of approaching the factory reset. So yeah, that's how you do factory reset. Now let's go into how to do the actual registration setup for AWS DeepLens. I actually get to use it. Yeah.